Hey, sunshines. So we're going to do lines of reflection and algebraic rules. So if I want to draw the line of reflection between these two shapes, they're not overlapping. I can kind of see where it is. Looking at it, it's kind of obvious that it's going to be the x-axis. But if I want to make absolutely sure if the shapes were maybe a little farther apart, what you're really doing is you're actually finding the midpoint between the two shapes. And you take 2 points that correspond. So I corresponds to I prime. I mapped onto I. So I want to find the midpoint because those 2 points, the definition of reflection is that they have to be the same distance on the opposite side of the line of reflection. So let's get a color that we can see. So I want to find the midpoint. So the midpoint formula is the average of the x coordinates and the average of the y coordinates. So point I is at 1, 2, 4, 5, 6, 7, -3. And I prime is at 7, +3. So the average of the x coordinates and the average of the y coordinates. Seven plus 7 is 14, but divided by 2 is going to be 7. -3 plus 3 is 0. 0 divided by 2 is still 0. So I'm going to plot that point on my graph. So now I know that my midpoint is actually on the x-axis. And then you do the same thing for another pair of points so that you have 2 points because it takes 2 points to create a line. For red this time. So point T is at 3, -3. T prime is at 3, 3. X coordinates y coordinates 3 plus 3 is 6 divided by 2, not 3. Whoops. Three plus 3 is 6 divided by 2 is 3. -3 plus 3 is 0 divided by 2 is 0. So my midpoint of these 2 points is going to be here. So now I know, now I've shown mathematically that my line of reflection needs to be in color. Go with hot pink. Nice, thick, hot pink line. So now I have my line of reflection. Since it's a line, we should put arrows on the end of it. So now I have my line of reflection drawn, and looking at the graph, I can use the graph here to find the equation of the line. There's obviously quite a few ways to calculate the equation of the line when you know the coordinates, but we're not going to go there yet. That's for another chapter. So the equation of the line, it's the x-axis, but that's not the equation. The equation for the x-axis is the line y equals 0. And so if I'm going to write the rule in R notation, that means I want R, and then let's make this nice and big. That's very tiny. R, and then your equation goes in the subscript. So there's two ways you could write the R notation rule. You could write it as R x-axis, or you could write it as R y equals 0.
Following starts in 5 minutes.
Now to write the reflection rule in algebraic notation, if you look at those coordinates, there's a pattern, right? The x coordinate is the same, the y coordinate was the same number, the same absolute value, but it just switched signs because it was switching sides of the axis. So what's really happening here, when you do algebraic notation, remember you're always starting with x, y, maps onto is that little arrow, and then x. So x stayed the same, so x is just x. Y flipped signs. So when you flip signs, that means you're multiplying by -1. So you just say negative y. So if your line of reflection is the y-axis, then I think you noticed in your work this week that it's the opposite way. X is the one that's flipping signs, Y is the one that's staying the same.